Welcome everyone. We're going to discuss the remarkable product and the so-called difference of two squares today. Yes, again the remarkable product, which we already got a few lessons on, starting with chapter 1 this year. And we're only going to discuss one in particular. We're going to take a look at this remarkable product. A plus b times a minus b. And then we know we can calculate the answer in one go by saying, well, that's going to be a squared minus b squared. So for example, a plus b times a minus of a plus 6 times a minus 6. You square the first thing, a squared, minus the second, in this case 6, minus 36. It won't surprise you maybe to see that this also works the other way around. So if I have it like this, a squared minus 36, I can also rewrite this like this. Or you could say this is a way of factorizing, ontbinden in factoren. We gaan in dit geval dingen die van elkaar af worden gehaald schrijven als een vermenigvuldiging. We're going to rewrite a subtraction into terms or factors times each other. Okay? So, well, the book describes it like this, and that's all fine and dandy by me. I think most important to know is that this is called the difference of two squares. So a squared minus b squared is called the difference of two squares. Or in Dutch het verschil van twee kwadraten. Verschil is dingen van elkaar afhalen. Dus je haalt één kwadraat van de andere af. And again, how this works, I'm going to discuss in the next slide because they show a lot of text here and I don't think it's very understandable how they present this to you. So let's check those 4 examples right here. And every next example is a bit more difficult as you're going to compare it to the next one. And remember, we're not only going to use the difference of two squares here, we're also going to use the other way of factorizing. How? Well, I'm going to show you in a minute. We start with this one, 9x squared minus 16. If I want to factorize this, then we have to remember that, for example, if I want to use the form a squared minus b squared, or you could say if I want to use the difference of two squares, I should know that this is a square and 16 is a square. 9x squared is the same as 3x squared, because 3x times 3x is 9x squared. And 16, well, 4 squared is 16. So how do I now factorize this? Well, use the difference of two squares by using the knowledge that in that case I may say that 3x minus 4, my first thing, minus or plus 3x plus 4. So 3x is the first thing, and the 4 is the second thing. If you say 3x plus 4 and 3x minus 4, that's of course the same. You can swap the plus and the minus right here. But be sure to have one minus and one plus, okay? Well, how can we make this more difficult? Well, if we're going to try to do this with 6x squared minus 24, you will find that I cannot write 6x squared as a square. Because right, if I use 2x for example, well 2x times 2x is 4x squared, and 3x times 3x, I always saw that already, that's 9x squared. So instead here you first have to find the common factors and put those outside of your brackets. What are the common factors of 6x squared and 24? Well, the common factors are, in this case, only a number, that's 6. Or if you write this down, 2 times 3, right? 2 times 3 times x. And this is going to be 2 times 2 times 2 times 3. Is that correct? Yeah, that's correct. And then you have the common factors 2 and 3, which in this case means I can get 6 outside of my brackets. Hey, and now I'm left with x squared minus 4, and this is something that I can use the difference of two squares on. Because x squared is the same as x times x, and 4 is the same as 2 times 2. So now I'll leave this 6 here, and I rewrite x squared minus 4 to the form x minus 2 times x plus 2. Or as I already mentioned, x plus 2 here and x minus 2 here. And this is now factorized because those are all things that are going to be multiplied with each other. So this is a factorization. C, you're going to do exactly the same thing, but in this case there is not a number that is a common factor, but a letter. In this case the common factor is x. So first get the x outside of my brackets. I'm left with x squared minus 25, which is x minus 5 times x plus 5. Don't take a look at this sentence yet, that is needed for exercise D. Exercise D, as you can see, we have to remember that x to the power of 4 is the same as x squared squared, which is the same as doing x squared times itself, right? And 1, yeah, that's maybe a bit weird to say, but 1 is also a square of itself. 1 is 1 squared. So I can now rewrite this thing to x squared minus 1 times x squared plus 1. And then some of you might say, well, I'm already done here. But no, in this case I can again use my difference of two squares knowledge on this part. Because here I can now say x squared minus 1, this is a square of x, and this is the square of 1. So I can now rewrite this as x minus 1, x plus 1, that is this part, and I still had the x squared plus 1 right here. And now the book says, pay attention, you cannot factorize x squared plus 1, because there's not a minus here. Try it. You cannot rewrite it to this kind of form. To do that, remember it's called the difference of two squares, so there must be a minus in that case. That was the case here, and that was the case here, but not here. So leave this like this. X minus 1 times x plus 1 times x squared plus 1. Again, I will show you a few examples in detail in another video as well. Good luck to you all.